Okay, moving along then. Yeah. Yeah. It's called dialysis tubing. It's very important to get that right because Miss Meta Jones no doubt knows that. But yeah, it's called dialysis tubing. All right, let's get to it. So today we're going to talk about acids and bases, and those are things you should be vaguely familiar with. You probably talked about them a little bit in grade 10 science, but maybe not, because it's one of those topics that sometimes we get to and sometimes we don't. Ah, look at that. So,
like if it turns a certain color, it's
okay, yeah, this is good.
like say vinegar is more acidic because it tastes funny. Oh.
Yeah, no, this is good actually. Um, so let's do this. Let's recall that we have acids and we have bases, and let's see what we can remember about them. Because you just listed, this wasn't how I was going to do this note, but actually I'm changing my plan here. I like it. You've inspired me with your remembering. Perfectly normal sound that perfectly normal adults make all the time. So that almost certainly isn't true, Hannah Colomb, but I appreciate you saying it. Okay, so acids. What did you mentioned taste? How do acids taste? They actually taste a very specific way. We have a receptor for acid on our tongues, and we call.
Well, it depends on the acid.
Well, no, actually, it doesn't in this regard. They taste sour. Yeah. Oh, did you? I didn't hear you say it. Whereas bases taste bitter. Speaking of bitterness, what else do you know about acids? You said they, somebody mentioned the pH. Does anyone remember what pH acids have? Less than, what's the weird middle number of the pH scale? 7. Strange, right? If you take grade 12 university chemistry, we actually learn why that number. It's not as completely random as it seems, so it feels kind of random. Which means bases have a pH of what? Yeah, that's right. Again, unless you know the math behind it, the pH scale is such a weird scale, right? Anything else? What else do we know about acids? What do acids are dangerous, right? Why? What do they tend to react with? Well, acids are dissolved in water, actually. Not so much.
Acids are in most
They react with organic material and with metals.
A lot of acids are in candy.
In other words, what's the word for that? Something that will attack and damage material. They are corrosive. Good. Yeah, citric acid. Which, like, actually, I mean, yeah, in fact, I keep some citric acid in the back that I sometimes use for beverages, but mostly use for cleaning, actually. Yeah, you want to take it easy. But, like, have you ever had, like, just citric acid by itself?
What is on malic acid, though? I know that's also.
No,
I don't know what it is.
It'll be good. Should be something. Was it not? Oh,
Very
I didn't mean to lie. It just happened. I think I probably just dropped it. There you go. No, you've tasted it. Oh, well, stop failing. You've tasted it before.
Yeah.
What's that on? 6 sour candies, right? Yeah, that's all it is. Do you know where? Yeah. Do you know where we get citric acid? The name might give you a hint. Yeah, citrus fruit shows up. And but every acid has a similar kind of sourness to it. Vinegar, right? That sour thing. But like, you ever had like sourdough or yogurt? You know, that kind of sour element to that. These are all acids. Acids have sour tastes. What makes an acid an acid? Do you know? Did you say your big brain makes acids an acid? If you remember, acids turn litmus paper red. Yeah, very good. Acids make it red. These turn litmus blue. In this unit, not this unit, in a couple of units from now, there's one called phenolphthalein. Is clear in acids. Have you guys seen this before? Put a drop of phenolphthalein in acid, it's clear. Okay, I'll show you. If nobody knows this one. So I have here an acid. What's this one? HCl. What's that called? Hydrochloric acid. Good. I actually have a base. This one's called NaOH. What's NaOH? No? Na. Sodium. And OH? Hydroxide. Sodium hydroxide. So if I take a little bit of acid, which is a clear colorless solution, I'll put it in here. Shh, thank you. So if I take a bit of that, and then I've got here, hydrochloric acid is what's in your stomach. Yep. And then I take a bit of this, which is also a clear colorless solution. Get ready. It's very exciting, guys. Ready?
I'm so ready.
Seriously, be excited. Okay. Ready? Ready? Nothing happened. Oh no, nothing happened. On the other hand, if I had a bit of base, let's see what happens. Another glucose. Okay, get excited. Get excited.
Screen.
That's a pretty color.
What happened?
Now drink it.
No explosion.
Oh, whoa.
Oh.
He's a magician.
Oh,
He's a magician.
stick around this time? There she goes. She sticks around.
What happened before?
So he's a magician. So like he just switched
Must be it.
he switched it, just went off his very short sleeve.
Well, you know what happened before, which is it just hadn't mixed yet. Because if I mix some acid back in, what's going to happen?
It'll go back to clear.
Right? So that's a reaction with phenolphthalein, which is another one we use for acid-base indication because phenolphthalein goes clear when it's with an acid. With a base. How would you decide? How would you describe that color that it turned?
Like a magenta.
Yeah, that's exactly the word we use. It's a magenta.
Get back. No, I'm trying to break your head off. It doesn't
Nice.
even Oh!
What is that? This TDO house?
in later labs, you're going to use that phenolphthalein quite a bit to determine the concentration of acids and bases. So that tells us kind of what acids and bases do. What it doesn't tell us is what acids and bases, fair enough, but also doesn't tell us what they are. See, great minds think alike. And fools seldom differ. But, sorry? We should go to London. Like London, Ontario or London, England?
London, Ontario isn't that bad.
I like London, Ontario, but I like London, England more. I'm just checking that spelling. Is that can't possibly be spelled right. Okay, I'm gonna trust that spelling. Okay, there are several definitions. We're gonna work with a theory called the Arrhenius theory of acids and bases. Arrhenius. It's named after a guy. It has Roman emperor vibes to it. I'm not going to disagree with that. I mean, I'm assuming it's a last name. If that anyway, the Arrhenius theory is that an acid is any compound that can release H plus ions. I don't know why I started the next line that early. When dissolved in water. Now, for covalent compounds, this can be complicated. Because most of the hydrogens in a compound, a covalent compound, can't be released. But for ionic compounds, this is exceptionally easy. And we already learned about naming acids, right? Remember that? We said that HCl, HBr, HF, and HI, these are what we call the binary acids because it's hydrogen, one other thing. How do we name those? HF, HCl, HBr, HI. What are all their names? HCl is hydrochloric. HF is hydrofluoric. HBr is? And HI is? Iodic, yeah. Hydrofluoric, hydrochloric, hydrobromic, hydroiodic acid. Good. So that's what an acid is. Just quick examples. HCl is hydrochloric acid. HNO3, that's hydrogen with a nitrate. By the way, for it to be an acid, what has to be true? What else has to be true? Dissolved in water. How do I indicate that? Very good. This is hydrogen and the nitrate ion. What would that be called? Is this hydronitric acid? No, hydro is reserved for these binary ones. What would we call this? Close. Nitric acid. If you remember, eight ends up being ic acid, and us ends up being. Yeah, I wrote it backwards. Sorry about that. Ite ends up being us acid. Very good. Sorry about that. All right. What about a base? Take your time. Sorry, I'm not trying to rush you. Take your time. I should say, actually, an ionic base. Because we're talking here about ionic compounds. An ionic base is a compound that releases. Does anyone know this? Does anyone learn this? What ion is released by a base? OH minus. Does anyone remember what that's called? OH minus is hydroxide ions when dissolved in water. So it is XOH, where OH is the OH minus ion, and X could be literally any positive ion. Now they have to be soluble, and there aren't actually all that many soluble hydroxides. A lot of hydroxides just won't dissolve nicely in water. But example, sodium hydroxide, lithium hydroxide, etc. Calcium hydroxide dissolves, magnesium hydroxide will dissolve. And once you get past ammonium hydroxide will dissolve. And once you get past there on the periodic table, they really don't dissolve well. So there's not all that many ionic bases.
Is the lab going to be about like pH scales and like limit?
Well, no, the next lab is actually going to be about double displacement reactions. But did you guys do the cabbage lab in grade 10?
Cabbage? I don't
No?
remember about cabbage, but we would take like different like household like things, like say.
Yeah, because there's a lab where we make our own indicator out of a cabbage, and it's really cool and really fun. So we might do that if time permits. We'll see. The nice thing is maybe if we do push the test to Friday, we could do that lab and not even do it as a write-up. Just do it. That'd be fun.
Let's do that.
We'll see. We'll see what happens, but I like that idea. Okay. Take your time. Take your time. I mean, I'm saying that, but I'm also vaguely pushing you forward. It's like a little bit of psychology that I'm like, take your time, by the way, hurry up. Being reasonably neat today. Fairly pleased with that. I'm doing my best. I'm trying. I'm not like as neat as I'd like to be, but I'm better than I sometimes am. All right, so let's pick an acid and let's pick a base and let's react them. Nice easy acid, give me one. Hydrochloric it is. All right, so we'll do HCl, which of course we know is hydrochloric acid. And we're going to react it with a nice easy base. Give me one. Base. Base. I mean, I guess water. I'll do lithium hydroxide. Sure you do. LiOH it is. Lithium hydroxide. All right. This has H as its ion, so this is an acid. This has OH as its anion, so that's a base. Does that make sense? But having said that, this isn't a special kind of reaction. You've already done this kind of reaction. How are they going to react? You've got a compound and another compound. When you have two compounds, what are they going to do? There's really only one thing they can do that we've learned about so far. Are they going to stick together and make a big monster compound? Have we learned about anything like that?
They're going to swap.
They're going to swap. What do we call it when two compounds swap? Double displacement. That's right. This is just a double displacement reaction. So, hydrogen had been, let's do lithium first. Lithium had been hanging out with hydroxide. Who's lithium going to be hanging out with on this side? Chloride. And we have to look at it. Lithium has how many electrons it wants to lose? 1. And chlorine has how many electrons it wants to get? 1. So I don't even need to do the table thing. What's the formula?
LiCl.
LiCl, which is lithium chloride. And then we need to know if that will dissolve or not. What do I check to know if that's going to dissolve or not? Sorry? What do you mean? This? No, because the lithium, remember, they're going to swap. So lithium is actually going to swap places with H. So H is going to end up with OH, and lithium is going to end up with Cl. Does that make sense? So we'll get to the H. Don't worry, we will get to it. But for now, we got to look at this, and we have to ask, will that dissolve in water, or is that going to be a solid? Remember that? Remember we looked at that? So I gave you guys that little table. It's also on your periodic table, right? So we're looking up lithium chloride. Is that a nitrate? No. Is it a chlorate? No. There's chlorides. What's the rule with chlorides?
It is soluble.
Unless it's silver, mercury, or lead. Are we working with silver, mercury, or lead? So it's soluble. So what do I write next to it if it's soluble? AQ. Very good. What's AQ stand for? Aqueous. Very good. Okay, there's that one. Now, what does the other one end up with? H ends up with? Great. And we can do the same thing. H has how many electrons to lose? 1. And OH takes a charge of -1 if you check your table. And so what's the formula? HOH. Good, which is true. Is there a better way to write that? That is correct. HOH is not wrong. But the other way to write it? H2O. What's that? Water. And I don't need to look this up. Does water dissolve in water?
No.
I mean, spoiler alert, actually a little tiny bit. Don't worry about it. Mostly it does not. Mostly water is just a what? It is a? Yeah, what is it, a solid, a liquid, a gas? A liquid. So what do I write here? L. It's a liquid. That doesn't look like an L, but it is. Okay, you know what? I'm doing my best. L for liquid. Yeah, water is a liquid. Look at me writing water is a liquid on a paper. That makes me, So you know.
How did we get here?
But the good news is, does this reaction happen? We said a double displacement reaction happens as long as one of the products is. Shut up. Now, back to my question. We said that if everything just dissolves, well, then that is no reaction at all, right? But we get a reaction if a gas is formed, right? Or if a solid is formed, or if a new non-dissolving liquid is formed. And in this case, water is a liquid, which means this reaction happens. Does that make sense? But the thing is, if every acid has H in it, and every base has OH in it, what will acids and bases always make when they react? Specifically water. Good. Does that make sense? If acids are always going to provide an H and bases are always going to provide an OH, if you put acids and bases together, they produce water. Which means if you want to neutralize an acid, if you want to get rid of an acid, all you have to do is add a base. And if you want to neutralize a base, all you have to do is add an acid. And if you add the right amount, you end up actually just making water. Does that make sense? You can take the most dangerous acid in the world, and if you slowly add a base to it, and just keep checking the pH, eventually you'll get to a point where its pH is neutral, where it's just completely safe. If you take the most dangerous base in the world, and you just slowly add acids, eventually you'll get it to where it's neutral. In fact, when I dispose of all our chemical waste, whenever we work with acids and bases, the disposal instructions are to neutralize it, which means you just keep adding, and we usually use, another base you can use is sodium hydrogen carbonate. It's a different kind of base, but it works as a base. Just baking soda. You can just add baking soda to an acid slowly. Again, you don't want to bubble up in your face, and it will neutralize it out and turn it just to water and then some salts, some whatever the other ions you're left with are, which will be much safer. And if you have acid, if you have a base, you can always add vinegar to it, which is a weak acid, and just keep adding that until it neutralizes down to just water. So you can always take an acid or a base, and if you react them, you get water. We call these neutralization reactions, but they're really just double displacement reactions.
So now we would need to balance it, right?
Yes, and in this case, how many hydrogens on the left side?
1,
Careful.
2,
And how many over here?
2.
All right, so we're good there. How many chlorines on the left? And on the right? Okay, so that's happy. How many lithiums on the left?
Okay, so it's already balanced.
So this particular one is already balanced, but the next example I'm going to give you does require a bit of balancing. Not too much, it's not too bad, but a little bit. Sorry? What?
She's not okay.
I always mind you. I worry about all of my students. You know, I love you guys.
I hope so.
Yeah, so, yeah, if you're freaking out, you just let me know. Let's do H2SO4. What's H2SO4? What acid is that?
God.
What's the SO4 ion? Sulfate, so this would be what acid? Say it again. Sulfuric acid, good. And what's this called? Sodium hydroxide, good. Which is by far the most common base. Sodium hydroxide is used in so many things. It's like an industrial cleaner. It's used in all kinds of chemical reactions. It is by leaps and bounds the most commonly available base. We have tons of it in the back. So I want you to balance this. And can I give you a hint?
Please.
Until you're done, it actually is really helpful to write water as HOH, because then you can think of it as hydrogens by itself and OH minus ions for balancing. Does that make sense? Which makes balancing a little easier. So I always recommend, until you're done, write water as HOH, even though that's stupid. But that way you would balance this hydrogen with these hydrogens. Does that make sense? And you'd balance the OHs with these OHs. And then once that's balanced, then you can just change that to H2O. I don't know if that made sense or not, but play with it. Try it. You'll figure it out. You're smart. I don't care what Hannah says about you. And by the way, she talks, so you guys should know. That's not true. I'm making that up. I've never heard Hannah say anything but lovely things about all of you people behind your backs, though to your faces, she's sometimes quite sharp. I talk about you, though.
I wrote something.
My second period class comes in. Like, wait till I tell you about my first period class.
I
That's
wrote
not true.
something, sir, but I don't know if it's right. So I'm going to go to the back.
I split that.
Bring my pen with me because he's my friend.
What's his name?
I don't know yet.
You should name him.
I should name him.
But you gotta think about it. You can't just.
Can you actually
name
scroll
him
back up?
John.
I missed something over
Of
there.
course, yeah. I'll just leave it with you, and you can scroll wherever you need. I'm gonna get myself a cup of coffee because I need a cup of coffee.
Nice. I was gonna. Oh, you're coming with me. What was it that I mishyped? This pork. It's meant to be so. Yes, man. I can't do it, bro. Do it.
Oh, I'm so curious. Now I know. Now I'm fascinated.
Oh yeah.
And then one day I did. Then one day I was just like,
Yeah. I had those shadows.
it's a long time.
I had
It's
to
not.
go in and change the H2O.
It's like a never-ending thing.
I remember Harper was
Biggest
talking about
paper
Borax.
ever.
That was up there. He did.
I want to do it, but I won't know.
I'm not surprised that nothing strikes in the art shop.
I'll put it back.
Helpful father.
I'll be today, you know.
Does he have his like pen on him? I'm gonna like draw something. I don't know where the pen is. Well, what a. Yeah, I'm gonna draw a smiley face.
Nope, destroying small tower. Okay, that's.
Okay, okay.
I think you're supposed to press this on the pencils. Up there.
Oh.
Fingers.
No, it's already on the pencil, isn't it?
Wait, well, it's also on that. If you look.
Oh, it's on the text. That's why.
So I think you put the pencil in.
Bro, it. Okay, yeah, okay. Whatever. I press in the pencil and it's
Well,
it's going
maybe
back
hold
to
up.
the text.
Press pencil and you see that weird little squiggly thing. That,
Oh, that thing?
yeah, with the hand. Yeah.
There we go.
What about me? Don't talk about me. I'm talking about you. I'm not being like, Wyatt. Wyatt, yeah. Right? No, I didn't do that. I didn't go in there and immediately start trash talking Victoria. Oh, I did. Shoot, bad example. But I didn't go in there and immediately start trash talking Ranger. I'm kidding. I didn't do it immediately. First, I poured some coffee. Then I trash talked you.
Well, you're better than me. I trash talked you my friend the whole entire time. That is
I don't know why I found that so funny, but that was good. All right. You are. No, you are. That's true. Okay, what's going to happen here? What's going to end up with what? Right now, sodium's hanging out with hydroxide. Who's he going to end up hanging out with? That traitorous bastard. Who's sodium with on the other side of this thing? Yeah, that sneaky devil running around behind hydroxide's back. I know about you, sodium. I know about you. I thought it's very nice. It's very nice. I like it. I'm just waiting to scroll down, and there's like a big middle finger like drawing or something. That happened to me once with my grade 10s last year. I did. They put it like further down the page. So as I scrolled down, it was just like a picture of a middle finger. I was like, thanks, guys. I appreciate that. Anyway, it hurt my feelings. Anyway, speaking of hurt feelings, hydroxide's feelings are going to be real hurt because who's sodium with now? Sodium is Na. By the way, how many electrons does sodium want to give away? Okay. And who's it ending up with? Yeah, beautiful. And what's the formula of sulfate? Great. And you don't have to have this memorized. You can look it up. How many? It wants to take 2. So if we just had 1 sodium, it can only give away 1 electron, but sulfate wants to take 2. So we need 2 sodium. So what's the formula of this? Very good. And obviously, we're never going to have to do this again, but H ends up with whom? That's right. And this is obviously, we're going to write this as H2O later, but for now, let's just do this. Because now, let's get counting. Left side, right side, let's go. How many hydrogens, not the OHs, do we have on the left? 2. How many hydrogens, not the OHs, do we have on the right? 1. So what do I need to do to fix that? Great, which will make that 2, right? Now we have 2 H's. Nice. And then let's keep going. How many sulfates do we have over here? No, the 4 is part of the SO4. Just 1. That's right. And how many do we have over here? Just 1. So that's good. How many sodiums do we have over here? And how many do we have over here? Wait a minute. How many do we have over here? You're right. I figured that's what you were telling me. How many do we have over here? 2. And so, of course, what do I need to put in front here? A 2, which makes that 2, which means they balance. And then lastly, we can look at our OHs. How many OHs over here now? 2. And over here? 2. And so we're good and balanced. And then finally, do I want to leave this as HOH? Yeah, if I want Trush to beat me up in the parking lot for my lunch money. But since I don't want that, how should I write it? H2O. There we go. You know, I think I could too, and not because he's like obviously in better shape than I am and more athletic, but I think the difference is this. I think he's got some shame. You know what I mean? Like, I think he's got some dignity, whereas like I just don't. Like, I would have no problem with just being like, start sobbing uncontrollably and like, don't hurt me, and then he looks away like, just back kick, man. Just right in the back. Just, whoa, okay. But you see what I'm saying? Like, I just think that he'd be like, or I'd be like, oh my gosh, look, Trush, there's like a child in distress. They need medical attention. And when he turned to do CPR, I'd like, gah! Just get him. So I think I'd be, and I'm heavy. Like, I can just kind of fall on him. I think I'd do all right, is what I'm saying. Yeah. That sounds like more work than I'm interested in.
Yeah.
Again, I can't stress enough, like, oh my goodness, look, a dinosaur. Bam! Just got him.
Nah, you just either just
Anyway.
grab his head and just
Okay.
fall back.
Anyway, the important thing to note is that when acids neutralize bases, you always get water, and then you get whatever the other ions were with each other. Does that make sense? And that's it. So we say you get water and an ionic salt. And salt doesn't actually mean just table salt. Salt is a general term for ionic compounds. But you get water and then the ionic compound that results from the others. That's it for today. You have the remaining time. What I'd like you to do is finish your little righty write-up from yesterday's lab. Well, questions on that?
The questions are posted.
Yes, questions are posted.
What time coffee? One more time. What is
Whoa. It's due Monday, but if you can get it to me today, that would make me a happy camper. Well, try. See what you can do. So this is due Monday.
Don't touch Mr. Orlando's coffee.
Now you didn't do this one yesterday, right? You weren't here. Do you have it prepped? Okay. Why don't we get you doing it? Are you here this afternoon? What do you have? You're not, right? Well, yeah, we come at lunch for that. But what you were coming at lunch for something already, right? What were you coming at lunch for? No, this. Yeah, is that good? You want to come at lunch and do this? Because yeah, we don't quite have enough time now. We might have enough time now. We might have enough time now. Yeah, here, come with me. Yeah, come back here. Did anyone else not do it yesterday? Do you have it prepped? Okay, actually no. What's your lunch look like? Perfect. Okay, both of you come at lunch. Get it prepped. Yeah. All right, get prepped, and then both come at lunch. We'll do it then. Cool? All right. That's better. That way we can kill two proverbial birds with one proverbial stone. What are you missing?
No, I'm not missing it.
Oh, good.
You need it too.
Yeah, no problem. I'm just reminding myself. Oh, sorry, since this can be
I'm just telling you.
Yeah. What was the question?
It's like something about like
Oh, yeah. No, this looks good.
oh, it's great.
Yeah.
It's running. And then
But that's one of them. And then what's the other thing we can get behind it? So that's good. Like that's just the balanced version of that, right?
yeah.
Yeah. So that's good. That's good. Might as well erase that. Otherwise, it's a little like those two different reactions. Yeah, good. Because that's iron 3 oxide, right?
Yeah, but
What's the other possibility?
Iron 1 oxide, right?
There's no such thing.
Exactly. That's
But
why
there's
it's
iron. What two charges can iron take?
1 and 3.
Not 1 and 3.
Oh, 2.
2 and 3. So the other one should be iron 2 oxide.
Oh, and then this one, I didn't know what else would react besides oxygen.
Over there. Do you see them?
That's just the balanced.
Yes.
Okay.
Orlando.
Yeah. Well, but this doesn't give you iron 2 oxide because one way to think of it is like the charge on iron is already set. This is iron 2, or this is copper 2. Right? That's copper 2 carbonate. So when it's copper 2 carbonate, you're going to get copper 2 oxide. Copper, if it gives away 2 electrons. How many electrons does oxygen want to get? Right. Copper 2 oxide will have what one?
Oh, this is copper. CuO.
CuO. Really good. And then balance it from there. And I think that's actually self-balancing.
Yeah.
Does that make sense?
From our results.
Yeah, we don't need that. But now, one second. I want to read it like you said. So then, in the first half, where we're reacting copper with oxygen, you already know one of the products you're going to get, which is you can get copper 2 oxide, which would be CuO. But you could also get copper Cu2. Get Cu2O. Very good. Now these, you do have to make. Those are the two reactions. Copper will make copper 2, copper 1 oxide, and it will make copper 2 oxide. That make sense? Those are the two things you saw. The second reaction only makes copper 2 oxide. which, by the way, we know that looks like
Nah,
black powder.
everyone's
That's
always
actually
good.
not
I'll
that
smell
like
good.
black
Like
powder.
I'll put like.
So that's the black powder we got on the copper the first time. But this is the red. Does that make sense? So those are the two reactions from part A.
So it'd be like CFEC2 right there.
If I spray it on
Plus.
like
No, it'd be this. This is the reaction.
This
Oh,
is
it's
not
not
for
to balance.
then that's it. That's why
Because this doesn't balance, right? How many
I
coppers on the left? How many on the right? Good. How many oxygens on the left? How many on the right? Good. So that's a big mess. You gotta balance it. Here, how many coppers on the left? How many coppers on the right? So far, so good. How many oxygen left? How many oxygens on the right?
You good?
No?
Oh, one.
Yeah, good. So you gotta balance both those. Does that make sense? Those are your reactions. Balance them. You got it.
I
Nice.
never
We're gonna see.
So from my results, I should have 7 equations to do.
Okay.
Right?
Yeah.
What are you doing right now?
I don't know your results, but did you get 7 reactions?
Yes.
Then yes, you should have 7 equations.
But the
to
thing
do.
is,
Yeah.
with like iron, no, it's like it can either be like charge 2 or 3, and I'm wondering if I have to do like both.
You should do both,
Why are you this thick?
but no. Sorry, you don't have to do both.
You don't.
It depends. Depends on was the iron starting out as a solid? In that case, you could get 2 products. Whereas
I
if
don't
it,
really think it did much.
I think the solid iron should have reacted with what? What should have reacted with the solid iron? Did the acid react with the solid iron? The copper chloride would have. The copper chloride definitely would have. Should have.
Yeah, then no, it didn't react with anything else.
Okay. Yeah, that's fine. So that's an easy one. Yeah, that should give you 2 products because you should get iron 2 and iron 3. So you should get 2 reactions for that.
No.
Annoying, but yeah.
My equation was the equation.
So I didn't.
There you go. If you don't know till you know, right? If you don't know, now you know.
I'm just
Me?
No.
Stop whining.
You know what?
Is
Whatever.
there a land now?
You can do that.
Yeah, we live there.
Yeah, looks great. Yeah, looks great. Obviously, right up there. It's on the wrong side, but yeah, looks good. There. See, now you can get rid of that. Well, no, that's important. What's that? Yeah. So these are the part 1 reactions, because there's 2 of them, right? And that's the part 2 reactions. There's only 1. So, it's question?
How do I do this?
I have no idea what to say.
I'm using the data you have collected from the activity series for hydrogen, hydrogen,
Sure.
copper, zinc, and iron.
Great. So what you have to do is you look at your reactions, right? And all you're going to say is like, okay, what was able to kick out what? So let's say copper.
Yeah.
Where is copper on your list? And the answer is anything that copper was able to kick out, it's above. But was copper able to kick out hydrogen? So it's got to be below hydrogen. Obviously, it didn't self out. That would make sense. Was it able to kick out magnesium? Was it able to kick out zinc? Was it able to kick out iron? So what's copper going to be on your activity series? It couldn't kick anything out, so it's got to be right at the. That's right. Then you look at, let's see one that seems to be the next lowest. Zinc. Could zinc kick out hydrogen? Okay, but it could kick out copper. So zinc should be above copper, but it shouldn't be above hydrogen. It should be above magnesium. And then zinc with itself, who cares? Because itself, should zinc be above iron?
No.
So at the bottom of your list should be copper,
Copper.
right? And then right above it should be
Zinc.
good. Now, which is next? Iron. Does that make sense? And that's all we're doing. So if it's able to kick
So,
something out, it's
There's
above it
one
on the
extra you have
list.
to do that I
Does
didn't.
that make sense?
And I'm not gonna do it
You get from them. I have faith in you.
because
I have faith.
there's
You never
supposed to
have
be
faith
one
in
extra
anyone.
for iron.
Everyone's just a disappointment.
As in like
You were confused some
iron
stuff
7,
there?
iron 3.
You need to like
I only
figuring
did
some
one.
stuff out.
No, people are just disappointing until I just feel indecisive and say they're not. And now Hannah's not disappointing.
Yeah.
Oh, that's good. All right. Before I ask you a very, am I
Oh, there's a big guy.
live?
Sometimes.
No, that's fair. That's fair. I agree. I do not disagree.
What?
I said I'm kidding.
Give me your hand. I want to write it.
Let's not do that. Actually, yeah, let's go.
Are you
Is
going
it
through
good?
something?
I rather
I'll
prefer
come back in
double
like
chocolate,
y'all,
but
don't
yes, it is
Oh, okay,
good.
that's great.
I'll just come back and watch it. I love it.
Like, saying that.
There's none of y'all are safe. Hold on. It's also gonna be at the weirdest moments too. too.
an activity series. Like,
Look at what you did. Shaded. Yep. How do you make it?
I don't know, because this is an activity series.
I'll give you that right when I can come back. Especially if you want it.
Yeah, I'll just take it home with me.
What? No, it's because we have first and second together.
Are you good?
Yep.
Yeah.
Yep.
Not you.
Yeah,
Yep, I'm
sorry, I
fine.
was just.
No sleep. Yet again.
Dude, you good?
Yeah. Today, yeah. I told you it could happen at any time.
Why do you have no sleep?
I don't fucking know.
Did I
Go
do
ahead.
something wrong?
I just
Hold on.
do.
I might have done something
And they happen out of nowhere. I had one this morning and that's why I brought this.
Really?
Yeah.
We could have got different reactions.
That doesn't make you got to do the same thing. You should have the same reaction.
But yeah, shit can happen at any moment. Happened from this, sometimes it's happened from that.
You look at it and just
Not really.
just because it's the same thing as another different reaction.
What?
Activity series.
Is it bad?
Unless I might be missing the reactions from. Okay, can I see your iron? This is a. So yeah. Two, one. I'm missing that reaction maximum. You react. You react.
Zinc is this one here. Your table is different than mine. Yours is in different order. Your iron is your zinc is backwards. Mine was because I missed this one.
So reaction and reaction. So wait a minute. Wouldn't it be no reaction because it's the same thing?
It gave me a reaction.
Reaction itself.
I didn't write down what the reaction was.
I'm tripping.
Where are you going?
Where's your
Okay, at least there ain't blood everywhere. Great, I can
Oh, see, yours is confusing me. We go.
When person was supposed to, you may not have gotten the same things as I did. So then you went to they don't have to change yours because based off of what you saw.
That reaction.
So
What is?
I'm not taking the multiple. The reaction I wrote down
Oh, I did mine.
other than what the reaction was. I believe I did.
I have a picture. I actually took a picture. I took a picture of it just to see. So, because he told me that, because that's the thing, I don't want to put. Like,
Every time there was a reaction, I wrote what the reaction was. But for the next one, the person wrote did not write it. Neither did you.
Fun.
yeah, I think someone that would be considered as a reaction. I don't think so. You didn't put this for.
I don't know.
To
change the color?
No, well, this is
No.
something, but
Just let me know.
I don't know.
Man, today sucks.
I got no rest. So. Let me zoom.
That's the next one. That's well, usually the usually say people see out here. This is yes, and that's yes, right? So this one's the next. This one. That's how you react to it.
See, look, I don't know if these are balanced, or if like this is even right.
Because this one has to be. I guess. This is two. Now I'm confusing myself so much.
So look, 3 copper, 3 copper, 2. Wait, yeah.
Oh. So how are you reading?
So the thing is, I had to rechange this.
Or you going down?
What do you mean?
Remember how it was
Are you going
CN
by
and
this
NO3?
way? So you
I
read
had
it
to change
or you
it
going by
to
this
CN
way?
NO3
You're
too.
seeing where
This
it's
way because it
Because
isn't
it
about
wasn't
all
balanced.
of this, because this is all different reactions. It's different things.
Because CN is 2, NO3 is 1. That doesn't work.
And also too.
Yeah,
This is
I had to change it to originally it was that, but I had to
since
change
we
it
can't react to hydrogen
to
like
Orlando.
air or whatever with things. I guess I'll have to look at this one, but then we need to stop using this.
Okay, so the activity series is related to the for hydrogen, magnesium, copper, zinc.
Afraid it's not stopping.
It said,
Well,
what I'm
Do you need to go to the office to get some ice?
Uh-huh.
Because that would help if you put it at the back of your neck.
It'll stop. I've had this before.
Is there cloths?
Not right now, but I've had them this morning. Look, if I feel lightheaded, then I'll go to the office.
You're losing too much blood, got it.
Look, if I die, then just okay, look. I told you that there's supposed to be 2 of them, and I only did 1.
Sorry, what's that?
Um,
So I actually did take a picture of when I was
This is
reacting
6.
and all. I took a picture of this. So I'm doing this.
This is 6.
Okay.
3 and 2 is 6.
What I got.
CL
Sure.
2 times 3
Yeah.
is 6.
Okay, what's your question?
You don't know simple math, bro?
Meter got different.
The
That's
3
okay.
doesn't tie into this.
That's okay. We don't have to get the same thing. So you're saying magnesium,
Look.
and then is your question like, is it
Here.
hydrogen X than iron?
Well, I don't
and
know.
hydrogen?
Yeah, and also,
Can I
do you,
intersect?
are you supposed to
Everything's-
count like
There's 3 coppers
sorry.
there.
These
2 irons for that.
That's right.
CL, CO, and they're both
Yeah.
6.
No, having said that, like if you thought you saw a reaction, you thought you saw a reaction. That's-
Oh. this
In other words, don't write
is
down what you should have
wanting
seen.
to
Write down what you
stop.
saw. Yeah. I would say like you have iron kicking out copper, but you don't have iron kicking out anything else, right? So where should it be on the way? It didn't kick out hydrogen, yeah, so it should be below hydrogen. So it should be there based on your data, and that doesn't mean that's what other people should get. That's what you got, and then hydrogen would be there. Does that make sense?
Yes.
Again, based on your data. Other people saw different things, they're gonna have a different order, and that's okay.
Okay, I'm gonna. Put that on the bridge.
Is this right, Mr. Leo?
I have no idea.
I don't know why. I don't either.
Hold up.
Say-
On you write hydrogen and big
But H. Yep.
Question one.
Oh.
When it says,
Okay, so I got one.
That's right. That activities here.
So
But do you know what I mean by the activities? So that's just that list of elements, right? Where at the top is the most reactive, the bottom is the least. So based on your reaction,
yeah,
not based
so
on the
they
real
use
activities,
that
based on what
as
you
kind
saw,
of
what's the
reactive.
most reactive, what's the least. Does that make sense?
But you would yeah, you can't really look at hydrogen.
So hydrogen, for example, of that one green, you would put it
Okay, I think it's stop.
Yeah, so that means well, at least so hydrogen can't keep the list on. So that
But they can
means
have,
it's
but they can have it at random, and I eat it.
hydrogen.
During my cookie, and then have it. Well, because
Organize.
Okay.
well,
Sure. That's okay. So what? So this you need to bring this forward, right? So if you right click it, you should be able to go to order and say like bring to the front. And that's in front at least now.
I've had nosebleeds.
And then like
So when you done.
it can't just go under this. It would just go like that.
It's too big.
Yeah, that's a good point.
I think those are kind of things every time you put it.
So I was gonna put
Yeah.
there's a picture frame behind this. If I move it.
Yeah.
And I can't get a small picture of a philosopher into the like shapes. You know how you used to do it on your thing? You had like you put a picture of something into like a shape, cropped into a shape. Like it'd be a circle instead of a square.
Yeah, I will say I always struggle with Google Slides.
Yeah, PowerPoint is so much better.
PowerPoint is much nicer.
Well, that's
Yeah. Well, what was able to kick it out?
The last one I just said, I didn't
Above
do
it. What was
anything
it?
else because it says you do any addition.
Like everything else.
So those should all be.
So it goes magnesium.
Two things,
Oh, and see.
Tell
Oh,
me.
I looked up other things. Well, I mean, it's got a lot coming out. Is what I'm saying.
I'm so sorry for you.
I'm not
Is
keeping
it?
the note.
I had to use like 10 pieces of it.
I like that.
Like some days are so bad that like the whole kitchen is ready. The entire thing.
Yeah, send that to me.
They should just use like humans. They should just use like humans from a red 45.
I'll send it on Teams. Yeah, right? Yeah, I'll send it.
Are they in good order?
Yes.
Yeah?
I put them all in.
They're the best.
I message on Teams. Yeah, well, I ignore you half the time.
That sounds like fun.
You have to do with me for
How
3
you like
years.
it? The basic one still. That's not saying
You
it's
gotta
less.
send me the test. That's the spirit.
I got it. I sent you the TikTok. You might not reply, but
I know that. I used to.
see you Tuesday.
Guys, have a wonderful weekend. Kind to each other. How you doing, guys? Greg, teach my classes. How we doing? Yeah. Perfect. I want a cup of tea. Oh, it smells beautiful. Already. Yeah.
Manual, sure.
Uh,
I have t-shirt. Oh, we're working
yesterday.
Yeah, somebody took it. Who took it again? They came and they specifically mentioned it. Was it the last job?
Why do you have this on your board? I think it was.
Look at the last job. I'm gonna go steal back my sharpener with great prejudice.
You should.
Yeah, I'm gonna go in there and mess things up. Might knock a couple things over while I'm at it.
I need to learn more riffs, Mr. Ryan. I need to do a session.
That's what I'm saying. Hey, look. How are you? Good. How's it going, Telford? Having a good day?
Yeah, it's pretty good. I had no freestyle Friday prepared today, so I typed into ChatGPT in front of their eyes, write a rap about pattern with tiles.
Oh, interesting. How'd that go for you?
Produced something that was kind of a slower rhyme scheme, like a really nice to have like a double time. I think I ran the beat off YouTube, and it was kind of funny to see it all come together live. But it satisfies them, so.
Last year I had ChatGPT write me a song with chords to apologize for my class for ditching them on a day when we had a lab plan. And it did, and I sat and played on the piano, and it was not good, but it existed.
I'm sure you guys have an output.
It had kind of a romantic overtone to it, which I was not looking for, but I guess when people want apology songs, it's usually like romantic in nature, but it wasn't really what I was looking for.
Yes. Right. An apologetic song respecting a fiduciary responsibility relationship between a superior and a I'm gonna do some marking. Yeah, maybe make some tea. What's this? Perfectly cut out. Oh, it's one of these records. Maybe this one. Oh, it's clearly you. You've got a small group today, right?
Well, they're usually a few months late, and a battle I desperately attempted to win.
So then you do a lap switch?
Yep, you did.
Yeah. Just waiting for everyone to show up as well. By 9:40 we'll do a switcheroo.
Yeah.
Works for me. I think I'll probably need 2 days for it, so get them all started today and go from there.
And do you want to grab, there should be an empty cart back there. Yeah. And that way you can just have them load up onto that cart when. How's everyone doing? Having a good day? Was period 1 poorly attended?
Yes. Yeah. Mine was packed. It was somewhat packed. Like all the bad kids were there, but like all the.
Howdy.
Am I late?
Yeah, you're late. You're late. You're late, you're not on time. Stop being late for my class, be on time! You're late, you're not on time. Stop being late for my class, be on time! What do I have to do? For God's sake, just be on time! That's the last show of class. Now for the minor. Every day I cry. That's not true, really. I'm wondering why? Why won't you just be on time? It's so easy. Just show up on time. I don't understand. I don't understand. I don't get it. Oh, yes, Chloe, please. No, not the first 15 minutes.
I want to get Emma out.
I support that. I love Emma.
I
You're welcome for that musical interlude. I'm sure it was lovely. Today, in a couple of minutes, we're actually going to head on down to Chuck's room because he needs to use our lab. So we're going to just go use his classroom. Today, we're going to do a few things. I'm going to... Grab a seat.
Since we'll be in the halls, does that mean I can...
No, it does not. Grab a seat.
Okay.
First things first, I'm going to return some work to you, which also means we're kind of, closing in on past deadline for some things coming in late. There's a few things from people I don't have, so I'll bug you about that. We can use this period in part to get caught up if there's something you have almost done or something you have hiding in your binder that you failed to hand in to me. Yeah. I made a cup of tea. Would you like a cup of tea? Okay, help yourself.
Mine?
Sure. Be neat. No messiness.
You got milk or no?
I don't, but you don't really put milk in this kind of tea. There's a bit of sugar there, though. Yeah, no, my milk is out, and I'm not going to buy new milk on a Friday because that'll sit here over the weekend, you know what I mean?
Alright, what kind of tea is it?
Sorry? Well, because I did a first round of tea for people in my first period class, and I thought some people might want some at the end, and nobody else did, but I did. See, that's what I'm saying. Whoa! Wow, take it easy. That's fine. Don't stir with that one, though. There's teaspoons there. You don't want to get that one. Somebody, as you can see, somebody put that in their tea, and that's why it's got all sugar stuck to it, because they're mutants. Honestly.
One of my old friends' houses, their sister would always just put the same spoon in her
Yeah, you
mouth
can't do
and
that.
back
Right?
and
Yeah, you
back
can't
and
do that.
back and back and sugar, back and
Right? See? You can like...
That looks like Mr. Orlando.
Sorry about your luck. All right. So, yeah, we're going to head down there in a minute. But at the end of the day today, I'm going to take primarily the main thing that we're going to finish up with today
I wish
is...
I had M&M's for my tea.
is yesterday's lab. And if you didn't get yesterday's lab, was anyone not here yesterday to do the lab? I think everyone here was. Am I right about that? Good. So I should be able to get these all in from you then. Really quickly, what did we do in yesterday's lab? Remind me. Sorry? What experiments? What did we do? We had 3 stations, right? Do you remember what we did? Yeah. Oh, wow. Very specific memory. Yeah, good.